Our first speaker is Mr. Joel White. He is the product and strategy owner at Bosch. And just help me welcome Joel, who's going to talk to you about camera as a sensor. Okay, Joel, it's all you.
All right, thank you. Thanks for attending. Thanks for having me. As was said, my name's Joel White, and I will tell you, I focus on one specific application of cameras, happens to be intelligent traffic solutions. I call it building intelligent infrastructure. Now, everything I'm going to talk about is, I'll just say it's the bleeding edge of what analytics can do today in cameras coming to market and just on the market. But what I focus on are applications and use cases built around accuracy of detection. And it's applicable in any market. I happen to be looking at intersections and highways. It could be a building, could be a parking lot, could be anything. The fact is that if cameras can detect, there are use cases and solutions that can be built off of those properties. And I'm going to give you a look into not only how it gets done, but why its value and why at this point in time, and I'll admit, you know, I'm an analytics geek. We're at a point in time where it's a tipping point. Things are changing, and we're at the beginning of what I'm going to call a new generation of capabilities and products. So I have lots of video. Like I said, I look at traffic. This is a MIC camera hanging in City of Columbus looking at this intersection. Why is it a MIC? It was the first camera we had that had the onboard capability to do what you're seeing. So if you watch these vehicles, we can detect, we can classify, and we can do things we could never do before. When we have up to a 50 to 60% overlap, we can maintain the definition between each of those vehicles. Today, the neural nets in the camera can classify pedestrians, bicycles, motorcycles, cars, trucks, and buses. So why is that important? What can you do with it? I think it's extremely important because anything previous to this generation of cameras could not do this. If you watch when the vehicles appear in the frame, we're detecting and classifying instantly. So the technology in these cameras is remarkable. And I like to say, we're at a tipping point. I've given this presentation a couple of times. I actually have 2 conferences I'll present at in the next 2 weeks. I think back to Gordon Moore, and I'm an old guy, right? Technology keeps changing, right? And why is this possible in cameras today? Why wasn't it possible before? I'll take you through that, and what I'll explain is, to me, if you're deploying video, and I've had end users tell me this, why not deploy a device that can not only give you that world-class video, but it can do far more. So same device can do much more than what I call world-class video. And world-class video, everyone can split hairs on how that fits together in this marketplace. Lots of companies can do that. What I'm going to point out are the advantages and why we can do the extended use cases far better. So we've been at this, putting video inside cameras or putting intelligence inside cameras for quite some time. Some people tell me 20 years. I think it's 15 plus, whatever it is. We have a great foundation of knowledge about how to make cameras do more than just stream video. Now the advantage we have, Bosch is a large company, we do many things. The primary business at Bosch is automotive. So when you're in your car, if you have automated cruise control or a lot of these intelligent sensing systems, you've got radar, LiDAR, video, all types of sensors in the car. Not only do we make those sensors, but we make the technology and software that's embedded to just about any vehicle you've ever driven. So think back. What does that mean? All that image processing knowledge, all that learning about how to understand a scene comes from what I call a higher order purpose. If I'm in an intersection and I'm counting vehicles, if I miss by 1%, that's okay. If I'm controlling your car going 75 miles an hour down the highway in traffic, If I make a 1% error, bad things can happen. So the level of precision the detection is created for is for a much higher order purpose than what we're typically doing in the marketplaces that I serve. But I can guarantee you very few people can do what we do, and there's some magic behind it as well, which I'll show you. So we were here. A lot of the devices we have out here use background subtraction models, which is the typical way analytics work. Then we moved on and continually progressed to this middle stage where we introduced a machine learning model where you could train the camera with custom detectors. We use them for special use cases. So here, we trained a model to detect the wheel carriages on rail cars. So now we can count how many rail cars move across a rail crossing. How fast are they going? Is it stopped? Is it blocking traffic unnecessarily? Once we can identify an object by training a detector, we can build use cases around it. But what I'm going to focus on here is this. This is where the technology is now and where it's headed. I think when you see the roadmap presentations that are coming up, you're going to hear much more about cameras that are going to have this capability. So in the cameras that I have downstairs, and there are some, they're running embedded neural networks in those cameras. And those neural nets are trained. So if you've ever used the camera trainer and lived through trying to create a detector, it's camera trainer on steroids. And these models are pre-trained by passing thousands and thousands of hours of video in front of actually humans who sit there and say, yes, that's the object, no, it's not. And then you build an algorithm and a neural net that gets embedded in the camera. So that's why it's important. So when you think about Bosch, and I said 20 years or 15 years, what we do is right at the sensor, we're grabbing data. It's not a bolt-on, it's not an add-on, it's not sitting somewhere else or an afterthought. Camera's built to be an intelligent device. I say it's in the camera DNA. It's really important because I'll show you why. In the unique thing we do that very few people do is we stream data. So I have cameras in New York City for a pilot. They've been on that block for 3 years. We're connected to low bandwidth 4G modems, or in some cases 2 cameras. It depends on the pole layout. But all we do is we stream data. We don't consume a whole lot of bandwidth. We look at video to measure ground truth. But the fact that we stream independent, anonymous data is a unique aspect of what Bosch can do. So in my world, in traffic, if you think about the promise of autonomous driving and where that's headed, and I just came from Germany, as they said, where we were at the ITS World Conference, which is all about how do you make autonomous driving and those types of visions possible. It's relatively impossible for an autonomous vehicle to negotiate, let's call it the streets of Washington, without assistance from the infrastructure. When you're coming up to an intersection, pedestrians, bicycles, anything can come from anywhere at any time. And a vehicle can't gather all that information independently. So deploying cameras in the infrastructure, when the cameras are independent sensors, now you're building a web of intelligence that creates an intelligent infrastructure that can support things like autonomous vehicles, high importance security application and use cases. If every camera you deploy is an active and accurate sensor, think about the use cases you can create and build on top of that platform. So that's what's important for me. And if you drive around the city here, you'll see that there are probably thousands and thousands of cameras that the city uses for traffic operations. Every single one of those can be doing what I'm going to show you. So if you've used our cameras in the past, you may have found some difficulty, and I am one who continually points out the flaws. That's why we're at the level we're in. I push the team to fix the problems. It's easy to detect when it's nice and sunny and everything's perfect, but what about at night? What about in bad weather? What about when the arm the camera's on is shaking like this in the wind? How do you maintain accuracy above 95% in those conditions? So I focus on failure. So I look for those failure points. I feed those back in to the team who then take those and improve. So I'll point out here, so if you played with an old camera, or not an old camera, even last year's camera that used background model, when you look at these large boxes, the standard background model, because these vehicles are so close together, or their shadows are interpreted as part of the vehicle, the analytics in those cameras would say, oh, that's one object. It's a truck or whatever. Sometimes it will oscillate because it can't figure it out. With the deep learning neural nets, we can detect every single vehicle independently. So this would be an error in background subtraction analytic. This cluster, this cluster. If I'm counting the vehicles moving down this road, which road authorities are obligated to do, their counts coming from video detection in the background modeling analytics would never be accurate enough. The detection with the neural nets in the cameras today, we know by measuring, and the strict measurements of ground truth are over 95% accurate. So what I tend to say is, if you're buying a camera, why not go for everything? Put a device in that can give you the world-class video, stream comprehensive data, and then you can build use cases off of this. So we build real-time use cases: stopped vehicle, pedestrian in the crosswalk, traffic congestion. So think about when you're on the highway coming down a curve. If you knew there was congestion ahead, and you may see it on dynamic message signs, but if it's automated and you can get those pieces of information in your vehicle, which is what we do, we can improve safety. We can also improve mobility and how those roads are used. Yep. Let's see if I can go back one. There we go. And at the same time, this is where my team is focused. Because those cameras are intelligent, they stream comprehensive data. And that data can be aggregated and used for analysis. And I'm demonstrating this real time downstairs, but we'll give you some insights. So what's changed, right? The device looks the same. And this one's running this background modeling, this one's running the deep learning neural nets. The only real difference is the CPU. So you have a CPU now that can handle the intensive processing of not only streaming the video, but running these advanced neural nets. And that's the difference. Hardware, specs, a lot of those things stay the same. So if you bought this camera last year, you can buy the new one this year and do much more. So this is a look behind the scenes. Yeah, if you have a question?
Yeah, well, I wrote, earlier the note was, can we achieve this through firmware? Obviously now we can't. So can we do retrofits for CPU?
No, you cannot. So, but it's a great question, right? Because I get it all the time. I want this, but I bought 200 cameras 10 months ago. What do I do? So on the roadmap, and I'll be deploying it actually in the next few months, is what we call an AI gateway that you can add. And for me, it would sit in the traffic cabinet, and it can take any Bosch camera or any other cameras, for example, and do the type of analytics you're seeing. Now, what's different, and this is what I'll show on this upcoming little series of video clips, is if you think back to what I said where we've been putting intelligence into cameras for quite some time, we know a lot about how to make the cameras work better when you think about detection. And I have a couple of slides coming up that are going to lead right into that. But when you look at this, I'll show these clips. This is the view, and this is how the engine in the camera is interpreting that scene. This pedestrian's almost black on black, but we can see him. So I look for failures, bright lights, clusters, groups of pedestrians, lens flare, all the things that typically would make the detection fail. But if you look at what we're doing here, there's some magic behind this. Now, I'll be the first to admit, right, there are competitors out there who say, well, we have neural net detection. We know how to do this advanced AI. Sure, lots of people can create neural net classifiers. Whether ours are better than somebody else's, that's like splitting hairs about who's better at low light or bandwidth or these other things. It's how you implement those in the device and make them perform is where I say the magic happens. And we have a team, and I'll show you, because if you watch this video, right, you can almost not see the vehicles in that flare area would be on my right or my left. And it gets worse, or it gets better from my perspective, because when we first started on this path with these devices, we'd deploy them, we'd look at the failures, and I'd send this video into the team and say, we need to do better because we're failing on detection here. And then what they do is they don't go and change the classifier. They change how the classifier is tuned to detect inside the device. And that, to me, is where the differentiation and the magic is. So, sure, we've got classifiers, and these numbers are just unique identifiers, so we can maintain each object. When we first did this, we could not detect any of these oncoming vehicles because of the headlight bloom. A little tuning, and you see it here. We're manipulating the camera engine to optimize for accurate detection. And if you just watch it, we won't miss a vehicle, right? I mean, I say we're 95+% accurate. In my team that measures ground truth, if there's an occlusion, like a car next to a truck, and we don't see enough of the car to detect him, that's a failure. So that's a black mark against our percentage. Now, is that fair? If you can't see it, you can't detect it. But that's the way we measure. We're very precise, very strict on how we present numbers and what we look at. So if you're in a city and you watch this, and there's some things in here, and I don't know how to advance this, so we'll suffer through it. But if you watch it, you'll see we're not only doing cars, but we'll do pedestrians, and there will be clusters of pedestrians coming. Of course, these people are too far away to detect. So what are we focused on now? We're great, we can detect. Let's detect at further different distance, meaning smaller pixel size to the camera. That's where we're looking to improve. So now, instead of needing, it's about 60 by 60 pixels on an object, maybe we can get it down to 30 by 30 and improve our detection distance. Improving our performance in low light. I mean, we're pretty good in low light, but if, here's an error. He was a person and then he converted to a bicycle. Now, you'll see that sometimes, but when I said our number is 95+, we're looking at vehicles crossing through an intersection, not classification, car, truck, bus, because our number will be closer to 90 if you want to look at accuracy of classification. So if you watch clusters of pedestrians, and I'm doing the dance because the clusters are coming, but these are things we could never do, right? Looking in this intersection, these two vehicles would be one. When I first sent this video in, we could not detect this person, and he's essentially black on black pavement. Not only was he hard to see, we could not detect him. And then that tuning, that magic that goes on about how these operate in the cameras enable what you're seeing there. So we don't miss him. Now those tracking lines, in order to track, we need consecutive frame by frame overlap. So if you're running 30 frames a second, we need to detect that object in every single frame so we can overlap and generate that tracking. And that's important because that's where we derive speed information. That's where we derive GPS coordinate information. All of the data that sits in that metadata stream is dependent not only on what the object is, but also its track and where it's moving. Now, why is that important? I have another presentation that talks about data, and all of this leads down the path of what can we do not only beyond real time, but also data. So I don't want to jump on that one. My presentation for that's this afternoon. This is actually our engineering and advanced analytics team in Germany testing what happens when people weave in and out of, and how do we maintain detection. I mean, this is real life, right? I mean, I get asked all the time, We want to detect how many people are on the train platform and Grand Central Station, how many people are getting on and off the train. That's hard. But if you can't do this, you don't even have a prayer of even thinking about how to approach that type of use case. This happens to be that block in New York City back from 2018. And people ask me, well, how many concurrent objects can you detect? I usually pause the video and say, you tell me, because I can't count them. But that's the power of what these detectors can do. So this is a little peek about how we do it. I did a seminar with our 2 PhDs, the one who leads the detection team, creating the neural net detectors. And it's, like I said, a closed loop. We have custom tools that were developed in the automotive business, and those are applied along with some common tools, but it's a continuous cycle. And it takes, like I said, thousands and thousands of hours of, we call it data. It's video. We need the content. In that scene in Pittsburgh with the pedestrians walking, if you look close, we're not good at detecting children because we don't have enough video to feed through the engine to teach it that people can be small. They're not, the typical size we think. So the good part of that is failure is obvious. Nobody's ever going to be 100%, but the platform is ready for when we have an improved detector model. We just update firmware, and now the camera not only can do what it did, but it can do it better. Maybe there's a new model. People ask me, well, can you count FedEx trucks that are coming through my toll plaza? Sure. Easy to do if you train a model to look for that FedEx truck or anything else. So anything's trainable. Now, his name's Florian Richter. When his team does what they do, they create that neural net classifier. The magic is here. There's a team that works on the integration, and this team has been together for over 10 years. So they know, where does it fail? Environmental influences are a big one. Tracking. When they detect an object, they try to derive information about it. Speed, size, direction, all of that information. And again, it's a closed loop. It's not just simple, here's a detector, slap it in the camera, we're ready to roll. It's how do you make that detector perform in the small footprint of a camera and perform with extreme high accuracy. I mean, that's what I focus on. I focus probably 100% on that sentence. That's what I do. So, detection's one thing, accuracy of detection's great, but what's the solution, right? Camera is a great sensor. Now, for me, we partner. So how do I create a solution? In my case, I mean, these devices are reading real-time camera data, and they're broadcasting out information or executing what I'll call detection protocols based on what the end user wants. The camera can do things up to a certain point, but if I want to put a message on a sign or broadcast a message that happens to be Siemens in what we call an infrastructure to vehicle message over DSRC, we need partners. And that's where my focus also is not only on how do we create the detection, but where do we partner to create a solution? So is it in the VMS? Is it in what's in traffic called an ATMS? There's all types of systems and integrations that have to take place, but the key is to leverage that detection capability and build out a solution. That's a big focus and really where it goes. So this is my last slide. I'm going to wrap it up here. The real message for me is if you're putting out video, put out video that can perform and do more in your environment. So monitor is a given. Everybody deploys a camera to monitor. I mean, I'm going to take that back because I do have customers who put cameras out just to detect and gather data. In a very special use case I can talk about when I do my data section, but it's monitor real-time alerts. So think of the use case, think of the scenario. When do I want an alert? How do I want to get it? Might be in a VMS, might be in my case, a flashing beacon for a wrong way vehicle about to enter a high-speed roadway in the wrong direction. You don't want to, send emails and broadcast data. You want to tell that driver, turn around because you might kill somebody. So it has to be immediate, it has to be executed at the point of detection, and that's what I call alert. And alerts can be many things, but it's real time. And then analyze. That's my data presentation where anything that the camera sees can be aggregated as data. Data is a big topic and it's useful. So how do we get the data? What can we do with it is what I'm going to talk about after lunch. And that is everything I had to show. I can demo this downstairs. I have a real-time setup. It's running one of these cameras, looking at a video loop. It's generating detection, which you can see real-time, and it's streaming data into the cloud, which I have on display. I can also show live cameras deployed through our remote portal connection. And I'll be honest, it actually worked better in Germany than it does in the room downstairs. I don't know why. Something about bandwidth, I'm not sure exactly what, but if you want to see what cameras can do, I have lots of things I can show. We can show hundreds of live cameras. Depends how deep you want to go. So I'll open it up questions. I'll answer anything you want for as long as Matt lets me stand up here and do it.
Do you have versions of which camera models have this advanced AI?
Yes. So if you think about camera roadmap, we recently introduced what we call Intiox, right? Now those happen to be the platform, which is actually the next session. But for me, even though those cameras have this open operating system and application capability, for me what the difference is those cameras have the horsepower to do what I showed. So when you buy one of these Intiox cameras and anything coming in the future, and we have more products coming, I'm not going to steal Sachin's thunder. He'll talk about that. But those platforms are even more powerful. So when I talk about, and I'm not going to say what processor's in the camera, but we find that processor, even though it does what I showed, is still a bottleneck and we can do more. More headroom is always better. That's why this in-cabinet solution with what we call AI Gateway is much more important. I always say cars can do all these magical things because you can shove a lot of processing power under the dashboard or under the seat in your car. And if you see how we build those components, you'll understand that. But squeezing it into the footprint of a camera is the hard part, and making it do what we're doing is the magic. Yeah.
What's the storage capability and how long is it kept?
On the data side? Yeah. You're stealing my presentation, but I'm going to share one thing with you because I've been doing data with different methods, which I'll talk about for 3 years. When I first asked that question to my end user, when I said, what kind of data do you want? He had a one-word answer: everything. And then I said, okay, I'll ask him, since that information was so valuable and gave me lots of insight, I'll ask the business side, how long do you want to store it? And another one-word answer. And if you can guess, it was forever. So with all that valuable information, now you have to decide what do you do, and that's what I'll talk about. So data can be stored forever. It's just a matter of retention time, storage costs, and all those things, right? I presented and I showed him a wrong way vehicle detection solution. He goes, that's great, but is it scalable, right? Scalable, I said, sure. Every camera is a sensor. We're connected to an LTE modem. We can put these anywhere as long as you give me power and I'm ready to roll. And his thought was, can I scale it financially? What's the ROI for me to go do this? And how am I going to justify it? So, same thing with data storage. Yeah.
Is it possible to make the color of the track and the object depend on the classification of the object? Or is it
So
all
Yeah, if you, I don't hear too well, so if you could use the mic, it'll help me.
I can turn it on. All right. Is it possible to make the colors of the tracks and the objects subject to the classification of the object? Like I want the first to be green.
Yeah, anything's possible, right? Now, what I showed in a lot of my video are the overlays, which typically nobody's looking at. I turned those on intentionally. And then the others with the 3D boxes, you would never see that from the camera. That comes from my engineering team as examples of what goes on under the covers as the camera's trying to interpret what it's seeing.
Okay, thank you.
Yeah, you'll have to use the mic because otherwise I'm walking back there.
Okay, so to my understanding, you had said that we could create our own custom object detections or classifications.
Sorry, say again.
So with this, we could create custom classifications or object detections.
So the classifiers today, we have 6, right? I asked for more. I settled for what I got, right? So it's people, bicycle, motorcycle, car, truck, and bus. I asked for segmented classification of truck, large truck, small truck, tractor trailer. That's hard, right? Because now you have to start to look at size. There are some people who say they can classify the make and model of a car. Anything is possible. It's just a matter of, I'll tell you, the first thing that really impacts what's possible is your field of view. That intersection I showed with the camera looking at a typical intersection approach, people say, well, can I detect license plates too? And the answer to that is not with that camera. Because if you want to detect plate numbers with accuracy, you need to put a purpose-built camera with the field of view required. And we've run some tests. I mean, even on a high-res 4K, you might be able to get 3 vehicle widths on a road with plate detection. But you need pixels on target to do those things. So, you know, there's all kinds of possibilities on detection. The platform and the engine is what's important. And can you add more into the camera? And I'm going to put Sachin on the spot. One day, maybe we'll have a model where you can create your own detectors and add them into our camera. Maybe we'll have a pathway for that. The answer is I don't know, but when you say, is it possible? Just about anything is possible is the answer to that. It's when will we do it? How will it get prioritized in the vast amount of work that's needed? That's really the question. It's always resources, people and money.
Joe, I think this would be a good question that we discuss in the roundtable.
Say again?
I think it would be good that we take up this topic about how you can customize what you can do downstairs. We can say that have a long.
How are you?
Let's pick it up in the
Well, my question was just related to like how sound analysis is going to tie into this.
Yes.
Dr. Dawson's expertise.
Yeah, so Sachin will cover that, and he knows more about it than me.
Doesn't pick one, dude.
Yeah.
Through the presentation, I see you using this a lot for counts.
Say again?
Through the presentation, I see you using it a lot for counts, bodies, vehicles. How much of this industry is moving for using cameras in reference to perimeter detection?
So we have lots of people focused on advanced perimeter detection.
Is that later on, or because it's kind of just focused on?
Well, like I said, I'm the traffic guy, so I look at it from a traffic perspective. We have companies that do integration with radar systems, with the camera, where radar will detect a person further out, tell our cameras to move in a certain direction, so now you can get visualize on to what radar detected. So I don't know that it's a single sensor to give you the what I'll call the high security perimeter detection. It could be multiple, but how do you tie those together in a solution that delivers the accuracy and detection that's needed? Maybe it's something Sachin could talk about as well. I know the companies that are working on these, but I'm not that tied in. I just want to wrap up. Thank everyone for your time. I love the honor of being first, so hopefully it was interesting to you all. And like I said, come down and see what I'm doing, and I can answer any questions you have. Thanks again.